guys, this is Sayukta Mohan, a third year MBBS student from Tashkent Medical Academy, Uzbekistan. So today we are heading towards second lecture of med chemistry and today's topic is surface chemistry. So let's see हम इस topic में क्या क्या पढ़ेंगे. Surface energy and surface tension, surface activity, surfactants and non-surfactants, absorption, chemisorption, adsorption on moving and stationary surfaces, Prenlich and Langmuir and Gibbs energy. Then last topic will be chromatography as a method of physiochemical analysis based on the selective adsorption chromatography methods. Okay, so I want to tell you that this is my Telegram channel जहाँ मैं सारे लेक्चर के नोट्स प्रोवाइड करूँगी एंड इवन अपकमिंग लेक्चर्स की लिंक्स भी. एंड दिस इज़ माई इंस्टाग्राम चैनल और दिस इज़ माई इंस्टाग्राम ID. This is my Instagram ID where you can ask me any query like related to Tashkent, how to study, what to study. Okay, so let's begin. Okay, surface chemistry. First of all, we will go for the definition. That is, surface chemistry occurs only at surface, not at the bulk. First of all, we should know what is surface and the bulk. So, for example, if I am taking this example of marker, so whatever the outer thing here it is surface, and इसका जो भी इसका अंदर होगा that is bulk. So this is surface and अंदर के जो भी molecules होंगे वो सारे bulk में आएंगे. So सबसे पहले हम देखेंगे कुछ basic definitions. So first of all, adsorption. Adsorption accumulation of species at surface and not in the bulk. Adsorption मतलब क्या होगा कि जो भी species का accumulation होगा वो सारे surface पे होगा and not in bulk. So surface can be solid also or can be liquid also. Then adsorbent. So here adsorbent, material on which accumulation occurs. जो भी material जिसका accumulation जिस पर accumulation होगा वो adsorbent कहलाएगा. And what is adsorbate? The substance which will accumulate. For example, here this is a scale. I'll explain from this. So यहाँ पे the material on which the accumulation occurs, like on this surface the accumulation will be occur. So this will be known as adsorbent, and the substance which will accumulate this will be known as adsorbate. Okay, then desorption. What is desorption? Desorption is removal of adsorbate from adsorbent, like the removal. Now adsorption in action, like हमारे पास एक बीकर है, उसमें गैसेस है ऑक्सीजन, अमोनिया और नाइट्रोजन. And these gases are exerting the pressure which is P, and due to its Brownian motion. Okay, so when we add powdered charcoal in this beaker, what will happen? The pressure will reduce because adsorption of gases on charcoal takes place. Now we will see difference between adsorption and absorption. Adsorption is surface phenomenon, whereas absorption जो होगा वो bulk phenomenon. Adsorption is concentration of adsorbate increases only at surface and not in the bulk. I already told you the difference between the surface and the bulk. Whereas absorption will be the adsorbate is uniformly distributed throughout the body of material. Like it will be the absorption will takes place on surface also and even in the bulk also. For example, like if we are taking a chalk and dipping it into the ink and removing it suddenly, so this is the example of adsorption, whereas the chalk dipped in the ink for a long period of time will be the example of absorption. Now what is sorption? Adsorption and absorption takes place simultaneously is called sorption. जब adsorption and absorption दोनों एक टाइम पे होगा उसी को हम sorption बोलेंगे. Now adsorption is an exothermic process. Exothermic process like whenever two things are combining, energy release होती है. So this energy will be known as exothermic energy, and the process will be exothermic process. Here delta H, that is enthalpy, will be negative. Due to the adsorption, movement of gas particles reduces. Like movement, random entropy is all about randomness, so entropy will be decreased, that is delta S will be negative. Delta means change. Now here adsorption is of two types, that is physisorption and chemisorption. So let's see. Physisorption occurs due to the van der Waals force between adsorbate and adsorbent, whereas chemisorption occurs when there will be chemical bond formation, and the bond can be of ionic also and covalent also between adsorbate and adsorbent. It is not specific in nature. It will be not कि मैं सोडियम गैस ही एब्जॉर्ब होगी या ऑक्सीजन गैस ही एब्जॉर्ब होगी. इट इज नॉट स्पेसिफिक, सो एनी गैस कैन एब्जॉर्ब, whereas the chemisorption will be highly specific in nature. So a given surface does not show any preference for a gas to be adsorbent, whereas it occurs only if chemical bonds are formed. This process is reversible, whereas this process is irreversible. Physisorption depends on nature of gas. Since it is exothermic process, low temperature is favorable, whereas it also depends on nature of gas and favorable at high temperature. When there will be increase or more temperature, the chemisorption will be more. Oops. Wait a minute, this spelling is wrong here. Let me correct. Okay, whenever I'll send the PDF, I'll make sure to correct this and then I'll upload. Okay, so here in physisorption, if the temperature will be increased, the physisorption decreases. More surface area, more adsorption will be there, whereas more surface, and the same thing will apply on chemisorption also, like more surface area, more adsorption. It is multi-layered while it is unilayered. We will see what kind of isotherm it is following. Okay, so now adsorption on moving and stationary surfaces. So let's begin with the key differences. Aspect, stationary surface and moving surface. So what will be the surface behavior as stationary surface है जो move नहीं करेगा, so it will be static, fixed, with this fixed geometry also, whereas moving surface will be dynamic, changing and changing surface areas. Contact time will be longer and controlled, whereas for the moving surface the contact time will be shorter, varies with flow. What will be the experimental control? Easier, and it will be complex. Like for stationary surface, equilibrium and kinetics can be studied, whereas for moving surface it will be influenced by fluid dynamics. Now what will be the applications? It can be used for the catalysis and chromatography also, whereas moving surface can be used for the flotation, emulsification, fluidized reactors. Now let's begin with the adsorption isotherm. What is adsorption isotherm? First of all, we can हम समझ सकते हैं कि यहाँ पे isotherm लिखा है, so iso will be same and therm is for temperature, so it will be under the same temperature or can say constant temperature. Adsorption isotherm shows amount of gas adsorbed with pressure. One more point I told you, I'll tell you that in physisorption if the pressure will increase, the physisorption or will also increase. Now we will study Friedrich isotherm, that is x upon m equals to kp to the power 1 by n. So what is x here? X is the mass of gas adsorbed, m is mass of adsorbent. Here 1 by n is intensity of adsorption, p will be pressure. Or can say here k and n will be constant. Depends on nature of adsorbent and adsorbent. Now let's head towards the graph. So here in on x-axis we are having x by m, whereas on this is x-axis, and on x-axis we are having pressure, and we are dividing this graph into three regions: low, moderate and high. So low region, that is low pressure region, will be n by n will be equals to 1. Therefore x by m is equals to k upon kp. See, I'll show you x by this is the formula. So x by n equals to kp. As 1 by n equals to 1, so this will be 1. So that's why the remaining will be x by m equals to kp. What will be the scenario for high pressure region? Here 1 by n equals to 0. As if this whole term, if this is the formula, and if we are having a power of 0 here, so we know that the whole term becomes 1. So x by m will be constant. And in moderate pressure region, it will be between 0 and 1. What will be the limitations? Doesn't predict a monolayer. It will be less accurate at high temperature and high pressure, even high concentration also. Now Langmuir isotherm equation. Langmuir isotherm describes monolayer adsorption on a homogeneous surface. Its equation is Q equals to Q max Kc upon 1 plus Kc. Here Q is amount of adsorbed per unit mass of adsorbent. Q max will be maximum adsorption capacity for monolayer coverage, as Langmuir will show the monolayer adsorption. C will be equilibrium concentration for solutions, and P will be pressure. And here K is the constant for Langmuir isotherm. One more thing I want to tell you, that why this is 1, 0, because see, in low region, this is the low region. Here graph is like a straight, kind of somewhat straight, nearly. That's why the value is taken as 1, whereas in the high region it's towards the constant. That's why it is 0. The constant to yahi hoga. So it's nearly 0, nearly constant. That's why the value is taken here is 0. Now what is surface energy? Surface energy is amount of energy required to increase the surface of solid. It is applied to solids. Surface tension, okay. Surface energy की unit क्या होगी? जूल पर मीटर सेकेंड्स, मीटर स्क्वायर. Surface tension will be force per unit length acting along the surface of a liquid, trying to minimize its surface area. It is applied to liquid, and the unit will be Newton per meter or dyne per centimeter. Now, what is surface activity? The ability of a substance to adsorb at interface. Interface could be solid liquid or liquid gas also, and change surface tension. Surface active agents accumulates at the interface and lower surface tension. Now, measured by reduction in surface tension or surface excess concentration. Now I will tell you that about surfactants versus non-surfactants. Surfactants will be surface active agents that reduce surface tension, and non-surfactants will be substances that do not significantly affect any surface tension. What will be the structure? It will be amphiphilic and may lack amphiphilic structure. What will be the function? Lower surface or interfacial tension, and it will form measles, whereas it will not form measles or stabilize interface. Examples: soap, detergents and bile salts, whereas the examples for non-surfactants will be glucose, urea and salt. Application: we can use in emulsification, detergency, drug delivery or foaming also, and here for nutrients, buffers, non-ionic solvents. And now at last we will go for chromatography. What is chromatography? Chromatography is a separation procedure for isolating various compounds of a mixture. It is just a kind of separation, like किसी भी दो substance को अगर हमें separate करना है, it can be like दो substance can be macromolecules like carbohydrate, protein, lipids. So we can use chromatography for that. The whole operation is time dependent. ये time dependent होता है and involves a mobile phase and a stationary phase. मतलब chromatography में दो phases होंगे और कैसे दो levels होंगे, stationary phase and mobile phase. The mobile phase may be a solution containing solutes to be separated and liquid that carries the solution through the stationary phase. Stationary phase may be adsorbent, ion exchange resin, porous solid और gel. Like stationary phase adsorbent भी हो सकता है, ion exchange resin भी हो सकता है, porous solid भी हो सकता है और gel भी हो सकता है. और मोबाइल फेज हमारा सॉल्यूशन हो सकता है जिसमें सॉलिड और लिक्विड हो, दैट कैरीज सॉल्यूशन थ्रू द स्टेशनरी फेज. दिस इज अ डायग्राम. दिस इज अ स्टेशनरी फेज where it is providing the passage for mobile phase. Okay, so now let's go for type of chromatography. So basically we are having 8 types of chromatography, that is adsorption chromatography, partition chromatography, ion exchange chromatography, affinity chromatography, gel filtration chromatography, paper chromatography, thin layer chromatography, and at last gas chromatography. So let's see one by one. Adsorption chromatography. It is based on adsorption of solutes onto a solid stationary phase. The stationary phase will be solid, for example silica. Mobile phase will be liquid or gas. It is used in separation of pigments, drugs, or even for plants extracts also. Whereas the second is partition chromatography. It is based on partitioning between two immiscible liquids. The stationary phase will be liquid film coated on inert solid. Mobile phase will be liquid or gas. The example is paper chromatography, gas liquid chromatography. Gas liquid chromatography and paper chromatography is a type of partition chromatography. Third, ion exchanged chromatography. It is based on electrostatic interactions between ions and charged sites on resins, used in protein purification, water softening. The fourth one is affinity chromatography. It is based on specific binding between target molecules and ligands on stationary phase. It has high specificity, like it is used for enzymes and antibodies also, sometimes for drugs also. Then fifth is gel filtration chromatography. It is based on molecular size. Larger molecule runs faster, smaller ones will be slower. Sixth one is paper chromatography, a type of partitioning. It is yes, I told you earlier also that it is a type of partitioning chromatography. In this stationary phase will be water in paper, whereas mobile phase will be organic solvent. मुझे लगता है बहुत सारे फ्रेंड्स ने पेपर क्रोमेटोग्राफी देखी भी होगी एंड आई थिंक स्कूल में की भी होगी. देन 7th thin layer chromatography. That is, it is a type of adsorption chromatography. Stationary phase will be thin layer of silica or alumina on a plate, and it is used in drug analysis and purity checking also. And at last, gas chromatography. Stationary phase will be liquid or solid inside a column. Mobile phase will be inert gas, for example helium. It is used in volatile compounds analysis. And here हमारा टॉपिक खत्म हो गया है. थैंक यू. सो दिस इज माई स्टार्टिंग. सो बीच में थोड़ा पॉज आ जाता है, बट ग्रेजुअली आई विल इम्प्रूव, बट आई विल नॉट compromise with the content, or can say with the notes. It is appropriate, and please subscribe my channel. Thank you.